In our last video, we looked at adding polynomials. Today, we'll be focusing on subtracting polynomials, which uses the exact same technique. In our first example, we're going to look at bracket 3x plus 3 bracket subtract bracket x minus 1 bracket. We have a polynomial over here, and we also have a polynomial over here. So let's go ahead and label this so that we remember what these terms mean. Now, more specifically, these are both binomials since they contain two terms. As we've discussed before, the prefix bi represents two, just like a bicycle has two wheels. I want to draw your attention back to the original question. When you have a pair of brackets, you have to look directly in front of the pair of brackets for any numbers that may or may not be there. As you can see here, there is no numbers present. However, there's actually a 1 hidden in front. And when you have a number in front of a pair of brackets, you're going to use the distributive property to distribute that number or term to everything within the brackets. And the operation you're going to use is multiplication. I'm going to zoom out and create a little bit more space for myself to rewrite this question with these ones added in. So I'm going to put a 1 in front, and I'm going to put a 1 in front over here. You don't have to put the 1 in front. A lot of people would consider this redundant, but I just want to remain consistent with my last video. As discussed earlier, we're going to use a distributive property to distribute this 1, which happens to be positive, to everything within the brackets. Now, over here, this is a little bit tricky. We have a 1, and we also have a subtraction sign. You actually have to distribute this entire -1 to everything inside the brackets. I'm going to push this up to create a little bit more space for myself. Let's first tackle this first polynomial, which we have over here. This one is simple enough. If you remember from our last video, when you multiply anything by +1, it stays exactly the same. That 3x stays exactly the same, and this +3 stays exactly the same, because anything multiplied by +1 stays the same. Once we've used the distributive property, you can remove the brackets, as you can see clearly. Dealing with the second polynomial is a little bit more complicated than our previous lesson because we have a negative number here. I'm actually going to do a lot of the work on the side. Let's zoom out and make some space for ourselves. The first thing we want to do is take that -1 and multiply it by x. You'll notice that I'm putting both these terms in brackets. When there's no operation between these brackets, it's actually multiplication. There's a multiplication secretly hidden there. When you have a variable with no number in front of it, in other words, it has no coefficient, there is secretly a 1 hidden, but not written in since it's considered redundant. I'm going to go ahead and write in that 1 to make things a little bit clearer. You're going to take -1 and multiply it by the 1 that's in front of the x. So 1 times 1 is 1. When you have a negative number multiplied by a positive number, that becomes negative. The x stays exactly the same. You do not touch it. Now, this looks kind of awkward. As I said before, you don't need the 1 written in. You could simplify this to just -x. However, if you want to leave the 1 in, you can, if that makes it easier for yourself. Next, we're going to take -1 and we're going to multiply it by the second term that's in that polynomial, which is also -1. Let's go ahead and do that work down below. Let's look at the number first. 1 times 1 is 1. Negative number multiplied by negative number is positive. but that positive sign, we want to remove it most of the time, so it just is 1. Let's go back over to the left, and what we're going to do is we're going to take this, that is going to be negative x, and over here, we're going to put this 1. However, when you put an x and a 1 right beside each other with no sign in between, it looks really weird. And if you remember, this 1 is actually positive. So at this point, you need to make that positive sign visible. And there we can go ahead and simplify this by collecting like terms. Let's first identify like terms. 3x is a like term to negative x. Positive 3 and positive 1 are also like terms. Let's go ahead and rearrange this so that all the like terms are beside each other. So I'm going to put the 3x and negative x beside each other, and I'm going to put the positive 3 and positive 1 beside each other. First thing is, let's simplify that. So 3x minus x is 2x, and positive 3 plus 1, pretty simple, positive 4. And that is our final answer. I'm going to scroll back out to show you all the work we did for this one question. In our next example, we have bracket 2x to the power of 2 minus 2x plus 5 bracket subtract bracket x to the power of 2 subtract 7x plus 6 bracket. Before we begin, let's identify our polynomials. So we have a polynomial over here, and we have a polynomial over here. Let's go ahead and write that in for ourselves. If you look closely at both these polynomials, you'll notice that there are 3 terms in each of these polynomials, which makes these more specifically trinomials because they contain 3 terms each. If you look at the prefix for trinomial, it is tri, and a tricycle has 3 wheels. In our previous question, I told you to pay careful attention to any numbers that may or may not be in front of the pair of brackets. Again, there is no numbers present in front of the pair of brackets. However, there is actually a 1 secretly hiding there that is not written in. We are going to be using the distributive property to distribute that term to everything within the brackets through multiplication. I'm going to go ahead and rewrite this question using the work I just did. So I'm going to write that 1 in front of the first polynomial, and I'm also going to insert that 1 in front of my second polynomial. As I've stated before, you're going to use the distributive property to distribute this positive 1 to everything within the brackets. Now, pay careful attention to the second polynomial. You are going to be distributing negative 1 to everything inside the brackets. Dealing with the first polynomial is very simple because anything multiplied by positive 1 stays exactly the same. That is 2x to the power of 2. That is 2x. Subtract 2x, and this is positive 5. Once you've used the distributive property, you no longer need those brackets, and you can remove them. Dealing with the second polynomial is more complicated, and I'm going to have to show you my rough work. Let's take this negative 1 and distribute it to the first term in the polynomial, which is x to the power of 2. Again, when you have a variable with no coefficient, there is secretly a 1 hiding in front. So let's take a look at this. We have 1 times 1, which is 1. When you multiply a negative number by a positive number, the answer is negative. The x to the power of 2 stays exactly the same. Let's do the other term. Negative 1 multiplied by negative 7x. 1 times 7 is 7, but when you have a negative number multiplied by a negative number, that becomes positive. that x stays exactly the same. We're going to take a look at the last term. We're going to take -1 and we're going to multiply it by +6. I'm writing in the positive sign. You actually aren't supposed to, but I'm going to show it anyways. 1 times 6 is 6, and a negative number multiplied by a positive number is going to be negative. Let's look back at our answers. Normally, you would want to remove this 1 as it would be considered redundant, so that would be -x to the power of 2. And again, over here, normally you would want to remove that positive sign, which would just leave 7x. Let's take these terms and place it back over here. So you have -x to the power of 2, 7x. But again, you'll see that there is no operation or sign between these two terms, and it looks really awkward. Therefore, you're going to make that positive sign visible. And our last term would be -6, and we're going to write that over here. You might notice a pattern here. When you multiply a term by -1, it stays exactly the same except the sign changes to the opposite sign. So x to the power of 2 becomes -x to the power of 2. -7x becomes +7x. +6 becomes -6. That is a shortcut you can use. However, I'm showing you all the steps. At this point, we're going to collect like terms. But before we do that, we have to identify like terms. 2x to the power of 2 and -x to the power of 2 are like terms. -2x and +7x are like terms. +5 and -6 are also like terms. Let's take the like terms and put them closer together. So the 2x to the power of 2 is going to be beside the -x to the power of 2. -2x is going to be beside +7x. And the positive or +5 is going to be beside the -6. Before we simplify this, let's go ahead and create some space for ourselves. We are going to simplify 2x to the power of 2 subtract x to the power of 2. That becomes x to the power of 2. Next off, we're going to do -2x plus 7x. That is going to become positive 5x. You can use a number line if you're unsure how we got this answer. And last but not least, we're going to take +5 and subtract 6. And that will leave us with -1. Therefore, our final answer is x to the power of 2 plus 5x minus 1. Last but not least, I'm going to make all my work visible in this final image.